Trigonometry Part 2, or Day 2, whatever you want to call it, deals with right triangle trigonometry. Now, in one of the Part 1 videos, we actually had given you this diagram of the right triangle, and this is the typical diagram of a right triangle. If you're going to call the right triangle ABC, you're always going to call the right angle C, and then the two acute angles are going to be called A and B. Alright, and again, the important thing to remember was that side A was always opposite angle A, side B was always opposite angle B, and then of course the hypotenuse, which is side C, is always opposite the right angle. Alright, and if you recall a couple things that we had from Trig Part 1, we had the fact that the two acute angles, which would be angle A and angle B, they added up to 90 degrees, right? They were known as complementary angles. And also we have the Pythagorean theorem, which said that a squared plus b squared equals c squared, right? The sum of the squares of the legs is equal to the square of the hypotenuse. Right? So now we'll actually get into the real trig, right? There are 6 trigonometric functions of angles in a right triangle. Alright? And what are they? They're sine, cosine, tangent, cosecant, secant, and cotangent. Each can be expressed as a ratio of the lengths of sides of a right triangle. So really the first thing to get out of this is that these things, right, sine, cosine, tangent, cosecant, secant, and cotangent, they're all functions. And a function, of course, right, has an input and an output. So in this case, the input is going to be an acute angle, right? Because we're only dealing with the acute angles of the right triangle, right? We're dealing with angle A and angle B. So we can take the sine of angle A, or the cosine of angle B, or the secant of angle A, or the cotangent of angle B, right? So the input is going to be an acute angle, and the output is actually going to be a real number that's a ratio of lengths of sides of the triangle. Alright? And what are those ratios? They're given to you right here. Alright? So if theta is an acute angle of a right triangle, so what does that mean? That means that theta would be considered the input of the function. Right? So theta is the input. So if theta is the acute angle of a right triangle, the sine of theta is going to be the leg opposite theta over the hypotenuse, right? That's a ratio. The cosine is going to be the leg adjacent theta over the hypotenuse. The tangent is going to be the leg opposite theta over the leg adjacent theta. The cosecant is going to be the hypotenuse over the leg opposite theta. The secant theta is going to be the hypotenuse over the leg adjacent theta, and the cotangent is going to be the leg adjacent theta over the leg opposite theta. So what ends up happening is people would always come up with a saying for this, and the saying for this was SOHCAHTOA, right? And what does SOHCAHTOA stand for? It just stands for, the S would be sine, O would be the opposite, H would be the hypotenuse. So sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. Alright, and I always like to give the second word also, which was choshikau. So we have SOHCAHTOA, choshikau. And what does the choshikau stand for? It stands for cosecant is the hypotenuse over the opposite, secant is the hypotenuse over the adjacent, and cotangent is the adjacent over the opposite. Now, do you really have to memorize SOHCAHTOA, choshikau? No, you can really just memorize SOHCAHTOA as long as you realize that sine and cosecant, cosine and secant, and then tangent and cotangent are actually reciprocal functions of each other, right? Because sine was the opposite over the hypotenuse, so cosecant was the hypotenuse over the opposite. Cosine was adjacent over hypotenuse, so secant was hypotenuse over adjacent. So these were also reciprocals. And tangent is opposite over adjacent, cotangent is adjacent over opposite, so those are also reciprocals, right? So you can really memorize either SOHCAHTOA CHOSHIRKOW or just SOHCAHTOA and then know what the reciprocal functions are. Alright? So the first thing that they would ask you to do really with these trig functions is just find all 6 trig functions of an angle, given, you know, diagrams of a right triangle. So I have a diagram of a right triangle here where I have a leg and a hypotenuse, right? The leg is 5, the hypotenuse is 13. So the first thing you probably want to do here is ask yourself, well, what is this other leg? If I call that other leg B, then that forces the leg that was given to me to be called A, and of course the hypotenuse is always C. So that actually allows you to now label this triangle. Angle B would be opposite side B, and angle A would be opposite side A, and of course angle C is the right angle. So the first thing I would really do here is I just say, alright, well, my Pythagorean theorem tells me that a squared plus b squared equals c squared, and I know that a squared is going to be 25 because it's 5 squared. B is the unknown, and c is 13. So I end up with 25 plus b squared equals 169. And if I subtract 25, I would have b squared equals 144. And then of course take the square root, so b would be 12. Right? So I can find the third side just by using the Pythagorean theorem. Right? So I didn't do anything with the trig functions yet, I just found the third side. But now that I have all 3 sides, now I can find the 6 trig functions of a given angle. And actually that's the first thing to decide. Well, what do I want to take the trig functions of? Do I want to take the trig functions of angle A or angle B? So I guess alphabetical order would tell me that I'll go with angle A, right, first. So what they're asking you to evaluate here is, what's the sine of A? What's the cosine of A? What's the tangent of A? And then what's the cosecant of A? What's the secant of A? And what's the cotangent of A? And those are all the abbreviations, right? Sine is SIN, cosine is COS, tangent is TAN, cosecant is CSC, secant is SEC, and cotangent is COT. So now I would just use my definition, right? Remember SOHCAHTOA. So if I remember SOHCAHTOA, I can find all these, right? They are all ratios, so they're all going to be fractions, something over something. So the sine is the opposite over the hypotenuse. So what's opposite angle A? 5. And of course the hypotenuse is always going to be 13. So the sine of A would be 5 over 13. The cosine of A now, cosine is adjacent over hypotenuse, so the acute angle adjacent A is, I'm sorry, the leg adjacent angle A is going to be B, which is 12, so this is 12, and of course the hypotenuse is still 13. And then when I do tangent, I'm doing opposite over adjacent. So again, we said the side opposite was 5, and the side adjacent was 12. So this is going to be 5 over 12. Alright, and then of course, knowing that the cosecant is the reciprocal of the sine, right? So if the sine is 5/13, that means the cosecant is going to be 13/5. If the cosine was 12/13, that means the secant is going to be 13/12. And if the tangent is 5/12, that means the cotangent is going to be 12/5. Right? So those are all my trig functions of angle A. And again, I could also find the trig functions of angle B if I wanted to, right? I could say, all right, well, what's the sine of B? What's the cosine of B? And so on and so forth. Right? And then I'd be dealing with this angle here, angle B. So, And now here's the thing you got to be aware of. Things get reversed now when I switch angles, right? When I was dealing with angle A, the opposite was 5 and the adjacent was 12. But now that I'm dealing with B, the opposite is 12 and the adjacent is A. So when I want to do the sine of B, I'm really doing the opposite, which is 12, over the hypotenuse, which is 13. And when I do the cosine of B, I'm going to do the adjacent, which is 5, over the hypotenuse, which is 13. So if you look, what happens here is the sine of A ended up being the same as the cosine of B, and the cosine of A ended up being the same as the sine of B, which makes sense because they're the two acute angles of the right triangle. So whatever is adjacent angle A is going to be opposite angle B. Whatever is opposite angle A is going to be adjacent angle B. So they just switch, right? The sine of one becomes the cosine of the other. The cosine of one becomes the sine of the other. Okay? And of course I could finish the other 4 if I wanted to also, but I think we get the point here. Right? So, bottom line is, what you should remember is SOHCAHTOA plus the reciprocal functions, or SOHCAHTOA CHOSHIKAW. Right? And that's how you'll be able to evaluate trig functions of angles of a right triangle.